Okay, so week 4, we're looking at particles. So let's create a new project quickly. So I'm going to call this module 1. Where are we? Week 4. Okay. Oops, into D, accept, and then save as. Save as into job, and let's call this particles version 1. Accept. Great. Okay, and I'm just going to delete these. There we go. Fantastic. Okay, so particles. Let's start by creating a geometry node as per usual. And let's call this particles intro. Dive in there and create a geometry. Let's create a test geometry pig head. Press P on my keyboard to get the parameters, and I don't want the shader, and we'll leave it on the medium difficulty. That's fine. So yeah, the wording can be a bit confusing if you're new to Houdini. You know, what are particles and what are points, and what's the difference? So basically particles are how we refer to points or particles within a simulation. So you can see here on the particles shelf, you know, particle, are all related to particles. And when we're in outside of the DOP, which is dynamic operators context, they'll be referred to as points. And you know, you can work on the geometry in the same way, so you can use the same tools or nodes to work on them. Really within DOPs and on the outside, they kind of, you know, they're just a point in space with a position. You can give it velocity in SOPs, and it will have velocity in DOPs. You know, you don't have exactly the same tools, but you can consider them the same thing. They go in to the dynamic operator as points and then come out, you know, we work on them as particles on the inside, and then they come out as points again. So how do we simulate? How do we make particles? So easy way to start out is by using the shelf tool here. You can kind of play around and you know, experiment with, you know, there's lots of different pre-built setups here. Let's start with source particle emitter. So just click on that, and it's taken this geometry. Oh, it says select objects for source particle emitter. So we select our pig head, press enter, and then we get our DOP. So we're in the dynamics area now, or DOP. We're in our DOP network. So what this done, if we go back to the OBJ level, so we've got the particles intro, which is the thing that I generated there. And that is being sourced. It's also generated, the auto DOP network. So that's just a network which changes the context from objects or SOPs into dynamic. So in here we can do any kind of simulation. And in here we are sourcing in that particles intro that we created, the pig head. And then we'll go over this in a moment. And then it's also created this source particles, which is, I don't know why they call it source particles, but it's not, because it's not the source, it's the output of the simulation. So when the simulation is finished, this is where it comes back out into the SOP area, and we can, you know, prepare it for rendering and stuff. So, you know, this is your basic simulation setup. You have an object. And this is just where the geometry is stored. You don't do much in here, maybe some physical stuff, but you don't spend a lot of time in here. But you know, you have a pop object, you have a pyro object, you have a vellum object. Any simulation, you'll have an object. And then we have a source. So this is where do we get our starting information from. So we get our pig head, and we are scattering onto the surface of that. Merge isn't doing anything here, we can delete that. We have the actual solver, so this is what is calculating, you know, what happens per frame or per substep. Another merge, which is not necessary. Gravity, which is our force, which will pull our particles down, and the outputs, which doesn't really do anything. You can cache simulation frames here, but I don't really do that. Okay, let's make the background dark. Helps us to see. And another thing you can do, which can be helpful, is press D, go to geometry, and you can increase the point size. I don't know, it's 5 or something, just to help you see. You can see that it's being referred to as a point, but we're looking at the particles, so you can see they're kind of interchangeable. And then we can see what's happening. Now that's running really quickly, so let's turn on this real-time toggle, so that will limit the speed to real-time, 24 frames a second. So there we've got particles coming in every frame, or subframe, and the gravity is being applied to them, and they are just falling. And you can see they've also got, if we go into attributes there, a little bit of random, so the variance there. So if I turn that off, so there's no velocity, nothing being added to the inherited velocity, then they will just go, oh, it will still go down. I need to turn this off to 0, I think. There we go. Now they're just going kind of straight down. So, well, that's handy. So you can create your velocity on the outside and bring it in. You can set it here. So give it, well, that's inheriting, but we can give it a variance here. I can turn that up. So you can see they'll just kind of fly out from the middle and kind of fan out randomly. You can give it more velocity in one direction. So get them to go straight up, and then they'll fall down. Okay. So there's something useful. So with the source, you've got different ways of sourcing. So this is now scattering onto the surface of our geometry. We can use all points. So it's going to, they're going to be birthed from each point per frame, which can be useful. You can do points, which will do, from the points, but not every single point. So it will, depend on other settings. What else? And all geometry, which is kind of weird, but can be interesting, which actually brings in the polygons. You can get some weird, if we quickly put a ground plane in, you'll see, when we have some collisions here. Ground plane, and merge that in. By the way, so with a ground plane, this is just a collider for the floor. It's important that when you connect this up, it always goes into the left input. And this is on the floor, so let's raise that pig head a bit. Source part, no, not there. I'm just going to delete that, I don't want to use it. I'm going to go in here, get a transform, and raise it up. 1, 2, like that. Back into my dot network. Okay. You can see that it's kind of deforming the geometry. That is kind of weird. You can put the variance back on, so the particles are kind of pulling those polygons along with them, and obviously that's just a mess, but there are ways you can do some cool weird effects with that. So let's set it back to not all geometry. Let's do points. Okay, no, scatter onto surface. I'll do that one. So another down here also, you've got you can use groups for sourcing those points. Emission attributes, which can be useful. So you can create a density attribute on your geometry, and then you can control, I want more points coming out of here than here, and then attributes related to that. Birth. So we got 2 ways of controlling how many points to generate. We've got this impulse activation and constant activation. So this impulse, if we read it, is each time the operator cooks. So that's per frame or per subframe, actually. So if you have substeps, you'll get particles on each substep. So we'll do, for example, 10 particles. If I turn this off, 10 particles, so we should have 10 at the start. Now if we go here, got 10 points, and then to the next frame, we've got 20 points. And I think, let's see if we give ourselves some substeps. If I go to the second frame, 110 points, yeah. So it's every time, you can see that now that we've got sub-steps, it's cooking the node multiple times per frame, or 10 times. So we get a lot more points. Now, put those back to 1. That's one way of doing it. And this parameter, it's a bit weird. It's just on and off, really. So I don't know why they have a slider there. It's either 1 or 0. 0 means don't do this. 1 means, you know, do this. So just think of it like that. Not you know, you're not going to get more points or less points. You're just going to get points, or you're not going to get points. Okay. So this will be the same thing as this, but per second. So really, with this, sub-step shouldn't matter. So in 1 second, so 24 frames, I've got 24 frames per second. I should have 5,000 points. So let's try that. 24 frames. More or less, you know, it's around or close to 5,000 points. Okay, and obviously you can raise that up or drop it down. What else? You got max points per frame, so you just put a limit on it. You've got a life expectancy as well. That's quite good. So let's that's 100 seconds, so that's very long. If we drop that down to 1, spacebar and F. Let me hide the ground plane. I don't want to see it. There we go. Maybe just put the grid on. Now you should be able to see that they're dying. So you see they're kind of dying once they get to about there. But it's always good to have a variance on this. You could do a variance of 0.5, half a second. So it's a bit more natural. Okay. You've got a group, so you can make a group for a particle that's on its first frame, I think. You can jitter the birth time, so when they're, you know, it's born, it's kind of offset it to help stop. Sometimes you can see stripes in your particle simulation, and these will help with that. Attributes, we looked at velocity. ID is very useful, so just leave that on by default. You know, especially when you've got particles being dying. If we go to our, you can see the geometry network looks a bit different in here into our geometry. So the points number will change when particles die, but the ID will always stay the same, okay, which is really useful for kind of controlling particles after the simulation. Stream here, just to get, it's like a different group, and binding there, yeah, we just want to bring in geometry. And then in the pop solver, so we've got substeps, which are important. So, you know, you can give it more or less substeps, can change the time scale, kind of slow motion effects if you want. This I don't really play around with too much. Collision behavior is cool, so, you know, whenever the particles collide with the ground or anything else, you can do different things with it there. Sleeping, so that's to make your simulation more efficient. So when a particle is not moving, you can put into sleep, and you can, you know, it won't be calculated after that. So that's it. We've got our gravity there, pulling it down. So next we'll take a look at what else we can do with particles.